Hello, I'm Gez Draycott and I'm here today to talk to you about SES-17 and about how SES-17 will continue to support our aero customers over the Americas. SES-17 was launched back in 2021 and it will provide services through till 2036. 67.1 West. This satellite is one of our biggest, if not the biggest, geosatellites in the SES fleet. At 6,400 kilograms, this satellite is equivalent in weight to an African bull elephant. This satellite really owns the king of the geo jungle over the Americas. Back in 2016, it was a personal journey for me to look at how we could design a satellite that would suit aero customers, be flexible, and provide high throughput over the Americas. And we did it. Full flexibility on the payload due to our DTP, our digital transparent processor. And this flexibility allows bandwidth and capacity and power to be moved around the satellite via our ARC, or Adaptive Resource Controller. And this flexibility benefits both SES and customers alike. So how does SES-17 provide this amount of flexibility and throughput? Well, when we look at SES at 67.1 West, that field of view is optimized for the Americas. And if we look at the Americas here, the ideal option would have been to keep it simple. We could have laid down beams over SES-17 that were all uniform in size. However, at SES, we realized very quickly that certain locations would require more throughput and smaller beams. And there'd be certain areas, again in that field of view coverage, that would enable us to provide larger beams, to provide that reliable, continuous service for our customers. So at SES, we designed SES-17 to focus capacity exactly where we need it to suit demand. And you can see with these beam changes that we have three different types of beams: 0.7 degrees, 0.9 degrees, and 1.2 degrees. And the Atlantic beams here are actually 3 degrees. And this allows continuation of service for our aero customers over the CONUS and then back over to the Atlantic to link them back to Europe. And the Atlantic beams, these are actually 3 degrees in size, providing that continuity of service. And how is this capacity fed? Well, it's fed by gateway beams, which we locate on very small gateway beams. And we have 16 of these gateway beams, providing capacity that we can uplink. And these gateways are SES co-located services, and from here we can uplink an actual value of 80 gigahertz of capacity. And that's really 16 times 2.5 gigahertz per pole, which gives us our 80 gigahertz of uplink capacity. And with these 152 Ka spots that we have here, plus the Atlantic beams, plus the larger field of view beams that we also have that cover the satellite, we have a total of 100 gigahertz capacity that we can deliver down into this area from 67.1 West. To summarize then, what we're looking at with SES-17 at 67.1 West are 152 Ka user beams, Atlantic beams, and also the field of view beams. And this provides us with 80 gigahertz of uplink capacity from our 16 gateways, which delivers 100 gigahertz of downlink capacity into the Americas region. So how does SES-17 utilize all of this capacity to deliver services for our aero customers? Well, let's dig a little bit deeper. SES have partnered with Thales Avionics to provide a service called the Aero Managed Service. This is the entire platform that is used to deliver services for our aero customers. And if we dig a little bit deeper again, the technology that we use is our Hughes Network Services service. This delivers throughput to each aircraft of over 200 megabits on the downlink into the aircraft. And then actually from the aircraft, we can actually deliver 12 megabits up from each aircraft. This amount of capacity into each aircraft is unrivaled in the Americas on a geosatellite. So the AMS has been designed in tandem with the technology that we actually use on the aircraft. When we look at the aircraft itself from side on, we use the ThinCom 2517 low profile antenna. This provides efficiencies and also less drag, but high performance. And we talked previously about the Ka spots on SES-17. And here, when we talk about the G/T of these spots, we're talking 15 to 18 dBk per Ka spot. And the performance of the 2517 antenna, this is very well matched to our Ka spots, providing the maximum amount of service we can. This antenna as well has been proven to switch between SES MEO and GEO services to provide flexibility for our customers in the aero sector. Another major differentiator that we talk about with SES-17 is the ability to port bandwidth and power around the satellite. This is key. When we talk about 152 Ka spots, we want to be able to deliver power and bandwidth exactly where we need it. And the way we look at that is having an amplifier which is connected to multiple spots. So we may have a small 1.2 degree spot, we may have a larger Atlantic 3 degree spot, and we may have a very small 0.9 spot over a very congested area. And with SES-17, with the ARC resource controller, if we decide that we would like to allocate more power to this beam, we take off a certain section of power from here, we put it into here and deliver more power into this spot. And this flexibility can be changed with uplink commands from our ground stations to reconfigure the satellite so power and bandwidth is allocated exactly where we need it to provide services. So to summarize, SES-17 enables us to provide services for our aero customers that deliver a continuity of service both over the Americas and the Atlantic, but enable us to then change the power and the bandwidth on the satellite to maintain the quality of service that we thrive to provide. The flexibility and the throughput for SES-17 enable continuity of service. When we talk about the 152 Ka spots, twinned with the Atlantic beams, twinned again with the power and the bandwidth flexibility that we have, we can move services and maintain the experience for our customers right the way through their journey, from over the Americas, Latin America, North America, then back over to the Atlantic. Another major differentiator with SES-17 is our ability to move capacity from gateway to gateway. And we need this for the aero services to provide that continuity of service. We all know that with Ka services, when we actually look at a raindrop, the Ka services, the wavelength can be exactly the same size as that raindrop. And again, the interesting thing, when a raindrop falls to the ground, the bottom of the raindrop will actually flatten out, and that matches the exact frequency of the wavelength that Ka services. So one of the challenges that we're going to have with SES-17, when we have services from our gateway, what we can actually do, if we have a rain cloud here, we're uplinking services to our satellite. With this rain cloud, we would move the services. The whole of our uplink would move from here, come up to the satellite, and provide us a clear uplink. So this facility, by switching all the uplink capacity, allows us to move that 5 gigahertz of capacity from this gateway straight round to this gateway, enabling continuity of service for our aero customers. SES-17 at 67.1 west. With that flexibility and that throughput of 100 gigs by 80 gigs, twin that with Thales, with our partnership, to provide the AMS. And that AMS can deliver 200 megabits into the aircraft, and we can put 12 megabits out from the aircraft. And this is all delivered by the HNS baseband system in 16 of our gateways for SES-17. The lifespan of the satellite will provide these services right through till 2036. The partnership with Thales Avionics and the technology that we have in SES-17 enables continuous, seamless service for our aero customers over the Americas region. You log on for your session and you have internet that's a standard throughput right the way through your journey.